Yeah, come on in. Yeah, no problem. Come on in. So let me start with a couple of housekeeping items. And then hoping since not many people are here in person, obviously I think some people are online. I'm gonna try my best job to um make sure everything is recorded, and then so if people are missing things, obviously you can watch the recordings later. Um, so a couple of housekeeping items. The plan for today is to start with explaining what the project is doing. I know I sent out the announcement with like the schema and the requirements in like bullet point. Everyone saw the announcement, right? Yeah. Okay, so announcements out there. Obviously, if there's things you don't understand, just please ask me. And then I'm gonna start with saying a few things about that. And then hopefully that will give you guys a good idea of what the final presentation will be like. Obviously, it's gonna be sharing screen on Zoom. You're gonna be demonstrating you have a chatbot that's functional, that solves whatever XYZ problem that you want to solve. And then there are a little bit of intricate detail I'm gonna walk through in just a minute. So that's first part of the class. Second part of the class, I want to continue to kick off slides to give you a bit more information on autoencoder. There's something specific to autoencoder that's tied up to machine learning, but then also tied up to student-teacher model. And then if you miss out on autoencoder, you kind of miss out on how to bridge that gap. So I trust everyone here knows k-means clustering. So we're gonna assume k-means clustering, you guys already know. And then we're gonna skip that and then pick up from k-means clustering because in that topic, in the next step is literally just autoencoder. And we'll explain a little bit about how that can be helpful. It might not be it might not be directly helpful to the project or the presentation, unless, of course, you pick the topic that require autoencoder. So we'll talk about what that sounds like. But throughout this class, I've given you guys a lot of tools and a lot of machine learning algorithms. I don't expect everyone to do every single algorithm. Unless you do the lazy predictor, then you get all the predictors out of the box. That's up to you. You can do that. End of the day, it just depends on your assumption of the user persona, and everyone has a different assumption. As long as it makes sense, then you're good to go. You feel free to use the lazy predictor so you get all the predictor out of the box. That's no problem. You can use autoencoder. That's no problem as well. End of the day, there's just going to be an API call in the chatbot, right? So that's that. And then, yeah, other than that, those are the only two things on our agenda right now. The rest of the class, I want to dedicate to basic question and answer. Whatever question you have about the presentation, anything that's unclear, anything you want to do, you want to bounce off ideas off, right? I want to make sure we have enough time for that. So any questions about the plan? Good. Okay. So let's kick things up with the two packages I gave you guys before. So in the beginning, we talked about the Wing agent and then the Wing agent X, right? So the first question is, what is the difference? And I'll show you guys what the difference is and how this can help you think about your final project. So I named them kind of similar on purpose. They're both pip installable. The biggest difference between these two things is Wing agent package is hard-coded. There's one API call. You make that one API call. It does some sort of Python coding for you. That's it. It doesn't have any routing, right? We're going to talk about that, what that means. Wing agent X, which is the second package, has that routing. And that router is built at the production ready step, right? So what I mean by that is, let me go to picture, and then I think I have a system diagram here. So what I mean by that is this. This router is called intent classifier. This intent classifier is something that it's crucial for you to know where to direct your API call. You don't have to take exactly the same Python code as what I have in this package. But if you think about it in your own way, it will probably end up look very similar, right? When you're talking to a chatbot doesn't necessarily know you're talking about an API call number one, and the API call number one is a logistic regression, unless you have a classifier particularly built and designed to do that. That classifier, it's this intent classifier. It's essentially just a function that scanning every single prompt that the user enter, and whatever user enter, it basically says a probability. 60% of the chance this user is trying to make a logistic regression, and therefore you should make API call number one. So the intent classifier's job is to do that. This previous package, this package does not have that. Okay, so that's the idea. Now let me show you the code. What do I mean by that? So if you go to the folder win agent, and then you go to literally there's just one Python function in there. There's nothing fancy there, just a chatbot class object. And then somewhere down here, there's a helper function, isolate the Python code. And then how you execute it, let me show you how you execute it. So you execute the agent, you run the agent, and then there's a while loop. And then in this while loop, literally there's just like a if statement. So the router, it's essentially just one line of code, complete 100% hard-coded. If there's a Python in the string that's generated by the chatbot, then I'm going to do something a little bit different. If not, then you carry on the normal conversation. So it's like something like, tell me a joke, right? Obviously, it's not going to trigger this line of code because the joke doesn't have .python in there. Now, conversely speaking, if you say, give me a scikit-learn logistic regression model, obviously this agent here, this general response here is coming from hang on one sec. It's coming from this client, and that client has .python. If you're talking about .python, right? And then also on top of that, this client is also hard-coded. Why is hard-coded? Because there's a particular ID, and then in this code, I mean, you do whatever you want, but like in this particular version, this particular ID of that Mistral agent is hard-coded, right? So let me show you guys what that look like. So if you go to Mistral agents, and then this is the agent that I'm calling. So you go in there, and then this is the system prompt. Literally, it just says you're a programmer, and then everything you do must have docstring, comments, and type hints. That's the requirement of how you should be coding. And hence, if there's any coding involved in that response, that .python will absolutely have to show up, right? So this prompt controls the response to look like that. And because this prompt controls the response to look like that, therefore, if you scroll down here, give me one sec. Here, this line of code, this pattern will make sense. And it will only make sense with that agent. It might make sense to other agents if you have like coding agents just in general, or if you're coding agents particular to Python. This, of course, this pattern will, of course, also be picked up. But if you have like something else, like I don't know, like if you use a SERP API to Google to do some web search, obviously this is not going to get picked up, right? Because it's a completely different pattern. So why am I telling you guys this? The point is this. If you just clone this repo and then just run this line by line, you will have yourself a hard-coded chatbot, right? And that will be a problem. And let me show you what the problem is. It will, of course, run, but the problem requires more human thinking. Okay, more human thinking. So let me show you what I mean by that. I already load this up, nothing fancy here, just install everything, import it, whatever, get your API key in there. Nothing's fancy here, but let me show you where things could go wrong. Let's say I start running this. Oops. Let's say I start running this. It will say, tell me a joke. If I just say tell me a joke, obviously there's no coding involved. So in this case, the .python doesn't show up. If it doesn't show up, no one's talking about any API calls. No one's talking about any Python script going on. It will just continue the conversation. In this case, it's just a joke, right? Great. So now, what if I want something, right? Give me a NumPy array. You know what? Let me make it a little bit more interesting. Give me 2 NumPy array that's random numbers, then plot it and save the plot. So it requires user to literally know how to code, even though the user doesn't know the syntax. At this moment, you will make an API call, and then the Mistral AI agent, like this guy here, will try to basically generate two NumPy arrays. So let's take a look at what it looks like. So it'll look like something like this. Import NumPy, blah, blah, blah. Here's a function, right? And then with docstring, with typings, the integer, the tuple, that's typings, and then whatever comment that you have, right? Generate two arrays, return array one, array two, plot it. Okay, so in this case, sure, it will work. I'm going to call this test one. And I'll say yes, capital Y, and then it will execute it. Here it says script executed successfully. Let me see if I can refresh. You see a plot here, and then this shows up a plot, right? Now here's when things start to go wrong. Why is that look like a time series plot? I didn't say anything about time, right? So that's one thing that things start to go wrong. Another thing, another way that things start to go wrong is, in the beginning, you still require the human to know what a NumPy array is, and then you still require the human to know what does it mean by plotting a plot, and then I actually have to say save the plot. If I don't say save the plot, it will just literally just plot the plot. And then if this UI is designed without that plotting ability, well, then guess what? You're not going to see a plot, and that's going to be a problem, right? So all those things are things can go wrong with the current with this package, this current package. Does that make sense? So those are the caveat cases you need to think about. But in that being said, even these problems are still little problems. They're bigger problems here. So let me show you what do I mean by that. Let's say this is my directory, right? Whatever's in the directory doesn't matter. Anybody run anything has some sort of directory, right? So in whatever your directory is, chances are you have some sort of files in there, right? In this particular case, I have a folder called sample underscore data, and I'm talking about case sensitive, right? Small case S, small case A, so on and so forth. You get the idea. It cannot be capital S, right? That's not going to work. So how do you get a computer to know that you have a directory look like that, and then there's like a JSON file in there, there's a CSV file in there? How do you get the computer to know that's the data you're trying to pull? And how do you get a computer to know which feature to use? Look, if I just say build a prediction model to forecast housing price, humans is gonna look at this and think about, oh yeah, I have data. I'm gonna build a prediction model. That's it, right? If you just enter this, it's not gonna get it. And the reason it's not gonna get it is because this agent, right? This agent has no knowledge that that's the particular place that you store your data, right? So what I mean by that is this: there's three dots here. You say copy path. I mean, you can just put a path here. The agent is not gonna know that's the path, right? So it's kind of your job to figure that out, to know how you design an agent in a way that this knowledge, humans don't have to look into it. Why is that important? It's important because now you have to wait for this whole thing to generate, and then it's going to be probably wrong. Why is it going to be wrong? Because there's no path here. I can show you where the path is. This is the file path, right? It obviously is different, right? This is when hallucination happened. This housing data.csv is called housing data.csv because someone else on scikit-learn or someone else on Kaggle uses sample CSV in Colab, and then they push that code on somewhere on Kaggle or whatever on GitHub, so that when the LLM get trained, it consumes that data and memorize, literally just hard memorize that this is housing data.csv, right? It does not have a way of navigating through your directory so that you can know. No, it's not called that. It's actually called California underscore housing underscore train.csv. And not only that, this file is actually in the sample underscore data. Does that make sense? So whatever this path is, in this case, I'm demonstrating this on Colab. So the path look like this, but in your own local directory, obviously you can look whatever that it looks like because it's in your own local directory, and you can have more than one files in there. You can have more than one folders in there, right? You can have nested folders in there. right? So it's up to you to figure out how that can be designed. Does that make sense? Any questions? So so then the resolution becomes, okay, now this doesn't work anymore. So I mean, you can give a name, but it's not going to work. You can say, I mean, I can execute it for you guys, so you guys can see what the error look like. Um, it's just gonna say fail to execute, and then this doesn't mean anything, right? Like I can't possibly look at this and be like, oh yeah, the error is because there's no directory. Like you couldn't possibly know that. So it makes debugging extremely difficult. Does that make sense? And it changes when you have a different environment. So you get the idea right off the box. The package requires requires a user to eyeball the directory and know what the file is. Okay. Same goes with pretty much everything else. Even if this thing runs, and then you get some sort of results, how are you gonna judge the let's say it's a housing price, it's a prediction, so maybe use linear regression model. Then how do you judge the linear regression results? If it's good or not, right? Are you going to add features? Are you going to reduce features, right? Are you going to use polynomials, right? All that stuff that we talk about the first half of class, all of those knowledge now playing here, right? So the point I'm making here is this package, it's a very static, very hard coded example. And then to fix this, you have to start thinking about how you take this code apart, right? Here, it's one function called run Mistral agent. And then if you start thinking about how to take this apart, the first question is, okay, in this while loop, once we have some sort of response or once we have sort of prompt, what are we going to do about it, right? So maybe there's something go before this, maybe there's something go after this line of code. Those are things to think about. Does that make sense? If this prompt is talking about the particular data or talking about a particular model, then maybe there's a one line of function here that reads that prompt and then start navigating through the directory to print out directory in some sort of JSON file, so your chatbot knows where that thing, where that CSV is, right? So those are the things to think about to customize this package. And then another thing that you need to think about is, while here, generate response is one LLM, and that LLM, it just triggered this agent. So not a whole lot of diversity, right? Because you just have one API call. So now you're thinking about, okay, how do I get more API calls in there? Like how does this function serve as like a main chatbot, and then it's able to redirect the user to different APIs based on their intent, right? So if you start thinking about that, then you're like, okay, this if statement is not gonna cut anymore, right? If means either or, right? If means either or. So, well, that's stupid. Why you only have two scenarios? Or why can't it be three scenarios, four scenarios, five scenarios, right? Exactly. So maybe here it can be some sort of mapping function. If you're going to use mapping function, maybe you have some sort of metadata, right? So if you start thinking about this package from that perspective, that's when this package start to make sense. So that's why here, if you go into WinAgentX, the first thing I think is important is metadata, right? So now you come up with a list of trigger words and a sample payload. So sample payload tells your chatbot you're able to make this API call if you have these payload. If you don't, or if you're missing one, then this API call is automatically going to be a fail one. So don't even bother making that API call, right? So where that logic is coming from, that logic, it's all that logic is actually in let me see, it's in here. So let me walk you through this, and then um let me tell you guys my expectation. So this is the main class object that basically invoke everything, right? So you initiate everything, and then here's the logic. So you have a while loop, and then you have an event stream. Event stream basically, like it's an array of dictionary that appends all of the conversation. And then that event stream will just grow indefinitely as long as the chatbot session is on. Okay. And then the first thing that hits is intent processor. So intent processor will look at the event stream and say, okay, I'm observing what this user is talking about. It sounds like he's making an API call. or it doesn't. If it's an API call, we then have a way of navigating to which API, because in your list of APIs, obviously there could be more than one API. So something like that. That's send message. That's one API. Google search. That's another API. And then generate financial report, whatever you want. That's another API, right? These are functions that's customizable and pretty much whatever you want, right? You can get API key in there. You can use fast API to do locally. You can do it on the cloud. You can do whatever you want. So that's that's where the logic is. And then the secrets is passed in. Right now, this is also hard coded. If you look at this particular code, it's also hard coded. I'm expecting the user to know all these secrets, disregard if they're gonna hit all these APIs or not. I can very well be in a chatbot that I'm not like I don't want to search internet at all. Like I just want the chatbot to give me some sort of financial report. Well, then if that's the case, the SERP API call is not needed. The SERP API key is not needed anymore. Does that make sense? So those are things to think about. And then once you have secrets, you have your metadata. Excuse me. Once your secrets and once you have the intent process tell you, oh yeah, you should go to this API. Then the last step is you resolve the dependency and then you execute it, right? So this is a big function. I can show you what the function looks like. This is a very big function. Let me go here and then let me go to helper. Match trigger word. Intent processor is here. And then register function is helper function. This is the resolve and execute. So this is a big function. So it observe the API event and then observe reversely, right? You don't want to observe starting from the beginning of the conversation. That's going to take forever. So you observe reversely. So you have a helper function here actually reverse a string. Okay. And then if there's no API call, then just don't hit anything, right? Return none, and then let the conversation continues. Okay. But if there is an API call, right? If there is an API call, then the first thing you should check is this API call something that you do have in your toolbox? User could very well ask something that you don't have in your toolbox, right? So that's a fail safe, right? Let that fail gracefully. If during a presentation, you let something fail gracefully, that's no problem at all. But during presentation, if you say something and then it didn't fail gracefully, that's kind of on you, because you design a software that it will have a bug in it, right? Does that make sense? Even though both code might look exactly the same, but one code has a fail graceful function in there implemented, but then the conversation can still continue, then that shows me that you thought about the backend, and the each piece is well defined, right? Does that make sense? So if user talk about something that your API toolkit does not have it, it's no problem at all. Just let it fail gracefully, and this line of code does that. Okay, so it is not the case that you don't have an API call. It is not the case that it's a regular conversation. The remaining case is it is an API call. It is also in your toolbox. Okay, so then your job is to find every single information that you could possibly find in the event stream, so that you could, at best, try your best to fill up those payload, right? So you have a for loop that literally goes through every single step in the event stream and says, oh, is this value in there? Is this value in there? Is this value in there? Is this value in there, right? If it's not in there, let's ask the user, right? Like, for example, if you don't have API key in the event stream, obviously you want to ask the user, right? Otherwise, how do you execute that API call, right? Things like that. Something like sending a message. Sending a message means you need to give me a message. If the user doesn't even tell you what the message is, obviously you don't know how to make the API call, right? And then this find things in the finding event stream function obviously consumes the metadata. So you're not like finding random stuff in there. You're finding things according to the payload requirement. So this line of code has the payload. So let me show you the metadata, and then each API call has a payload. Does that make sense? So sending a message means you gotta tell me who you are, and then you gotta tell me what message you want to send. Like, my name is Yiqiao, let's meet at 6 p.m., right? That's like the basic stuff about sending a message. So if a user doesn't tell you those things, the API call is not going to work, right? So during the presentation, I don't care what API call you want to make, right? But anything, any API call that you design, you need to have some sort of basic logic going in there. Linear regression obviously has to have an X, has to have a Y, right? Otherwise, how do you even run that function? Doesn't run at all. So if a user doesn't say that, user just say, yeah, I just want to run a linear regression model. Well, that's not going to work, right? You didn't tell me what is the X, what is the Y. So your chatbot either is smart enough to do it out of the box, complete automatically, or if your chatbot is not that smart, then you better ask the user. But let it fail is not an option, right? Because if you let it fail, then obviously you have not thought things through. Any questions? Okay. Yeah, so that's that. And then let me show you the resulting consequence of that. Same Colab environment, have everything installed. Here I actually use this version. It's actually an old version. I'm doing a couple of more edits on new version. So if you run the latest version, if you just do pip install without this number, it might just crash on Colab because I actually have a different version installed on MacBook. So don't worry about that. For the sake of demo, I'm gonna stick to 0.4.2. And if you want to reproduce this code, obviously stick to 0.4.2. So let me show you what do I mean by that. And I'm hoping I get this to work. So if it's tell me a joke, there should be no API call related whatsoever, right? So let's see what it says. It says no API call found in the event stream. So this eyes emoji tell me that at that particular point in time in the event stream, the intent classifier agent has not detected any single API call related to what we're talking about. And it's correct. Okay. So now I say, let's say something interesting. So I'm going to use one of these API. So at least we know what's the correct way to do things. The correct way to do things is exactly based on your definition. If your trigger word is generate company report or whatever, then say that. Okay. So let me try that. I'm going to move them here. So hopefully you can see them better. Let's say generate company report. I want to generate company. I'm going to add another word in there just to mess things up a little bit. Okay. Now it says, hey, hold on a second. I'm scanning the conversation in the event stream. Now I've detected that you're talking about an API that we currently have. Okay. So, and it actually says the API's name is generate_financial_report. So now it's routing the conversation to a particular direction that I know for sure what is going to trigger, what is the payload, and what is the output. Okay, so this alert system warns me that the code is doing what it's supposed to do. Of course, if you're building an actual chatbot, you don't have to show user this alert system. This alert system is purely for debugging purpose. Okay. Okay, so now it's not a regular conversation anymore, right? Now user is hitting the API, and then the intent classifier says, now we're going down this direction. The resolver now says, look, I couldn't possibly execute this API because I don't know what company you're talking about. You need to tell me what ticker the company you're talking about, right? Obviously, user here can still make a lot of mistakes. User can say Apple like that. Well, that's not going to work because that's not a ticker, right? So those are all caveat cases you have to think about. You can let it fail. You can say this is not a ticker, right? You can add something here, say like parenthesis ticker require all large cap, right? You can enforce something like that. If user doesn't say that, let it fail. Okay. So now I'm gonna say Apple, or I'm gonna make something out Tesla. Now it says, hey, do you want to save a PDF? Now this is when things start to get tricky. Obviously, if this is the first time you're seeing it, you couldn't possibly know what need to be entered there because I haven't told you, right? That's why every API product has an API reference, has API doc, right? That's what the API doc's job is for, right? They need to tell you this is the API call. and you need to send a model in here. You need to send a picture in here. Picture is PNG or whatever, right? That's what this is for. And when you're designing a chatbot, well, obviously you know that, right? Because you have metadata, right? You have metadata. Even if you don't like what I'm doing here and you want to save your own version of metadata, you should have at least something similar, right? You should know what the trigger word is, and you should know what the sample payload is, right? So this spits out the sample payload so that the resolver knows what is it, what it is that the function needs, and what it is that the function needs to ask user what to enter. Okay, so let's continue. Ticker Tesla, say PDF, this is a Boolean. Okay, so I say true. Send email. Send email is also Boolean. Okay, so I say true. Email to email is a string, so it's the email address. I'm just going to use my personal one. I'm hoping that my API key works. If it doesn't work, it's almost guaranteed it's an API key problem or some sort of in this case, the Yahoo Finance problem. So this happens sometimes, not always, but it happens sometimes. When you hit Yahoo Finance a certain number of times, it will just crash, right? So that's my fault for not taking care of that. And in this case, it recognized to make that API call, but it didn't work because Yahoo Finance give you an error. So this is like a live example to let you know that sometimes even though user can give you all of things that you're supposed to give, but I did not budget that the underlying endpoint that I'm trying to invoke can still fail, right? So in this case, what I'm supposed to do is I'm supposed to have in that API call, which is here. Let me show you how to fix that. So in the API call, list of APIs, and I scroll down to the company's report. Hang on, just one sec. So here, this function, I will like based on this output, I would say that function is incomplete, right? Why is it incomplete? Sure, I'm sure it works from time to time, but it is incomplete because when you are running this ticker function, there's no try except statement. You did not let it fail gracefully. Even if a user is giving you all these things correctly, you did not check if this code itself works, right? So obviously something like that, like if you do what I did here, obviously you get points taken off because you didn't think about the back end thoroughly and you didn't cover all grounds. Does that make sense? Let me try a different one and see if it works. I think the Google search, I think that one probably works. Let's see. Say again. Google search. I want to do a Google search, something like that. Okay, what engine you want to do? I'm gonna say here. Let's go to this step by step. Engine is a string. Okay, so I'm gonna say Google. Query. Okay, so I'm gonna say something that we all know it could be true. Like I'm gonna say weather today in New York. Location, New York. This number is number of items going to come out from Google search. I'll just say 3. Hopefully it makes the Google search. Hopefully my serve API key is correct and it's up and running. If those things are true, it's supposed to give me something. So there you go. I think it only gave me 2. So obviously that's another bug. So as you can see, when you're dealing with large language model, there are a lot of caveat cases that doesn't always give you what you want. And this is another example. But it did work, and then it gave me something that I'm hoping this is today's weather, right? So morning 38, afternoon 44, a little bit of raining. Okay, I'm gonna pretend that's kind of like this weather that we're having right now. Let me click on that just to make sure that, yeah, okay, so that's the website, and then that makes sense. So there, so you just made an API call. It consumed all of the variables from the payload, and it made the API call correctly, got the response back, and then you have some sort of markdown table, and you can present it. Does that make sense? Any questions? Okay. And then just to jog your idea a little bit more, I have a bunch of like random stuff defining here that, of course, if you want to take it, it's up to you. It's not required, Like for example, this one, it will generate a Word document. I can show you what that looks like. So let me go to my instruction, Word document. Let's say this one, generate a Word document. So I say, I want to create a document. Here's another one. That's a good thing. I'm actually glad this happened. So what's happening here is this. What's happening here is the dependency resolver that I talked about earlier failed to realize that we are in a separate API call. It somehow still think that we're in a previous API call. Does that make sense? So that's another problem. So the way to resolve this, the way to solve this problem is these trigger words sometimes could be very similar from one across the other. If you have let's say you have 100 APIs, somewhere down the road, like if you have an API that generates PDF, and then you have an API that generates Google Doc, and then you have an API that generates Word document, somewhere down the road, those trigger words is going to get like mixed up. There's going to be a lot of overlap, right? If I just say I want a document, how are you supposed to know you want a Google Doc or Word document or whatever other document or PDF, right? How are you supposed to know that? You don't. And even amongst humans, you don't. If I say I want to open a document, you're gonna ask me, what do you want, like PDF or Word document, right? So in this case, it's basically a mimic of that problem that you also need to think about. If you're designing API calls that's very close to each other in terms of its prompt, you need to figure out a better way to take care of that. In this case, I did not, because these trigger words are just randomly generated by ChatGPT. Obviously, somewhere down the road, it will get mixed up. Exactly. So unfortunately, nothing you can do. The only thing you can do is just stop the session. And then once you stop the session, you have to restart it, and then you have to go through the whole thing again. Any questions? No. Okay. Yeah. 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 Correct. So one API call could have other API calls inside of it. Yes. So I can show you another example. It's very convoluted. So I'm going to try my best to explain it. There is a function here that I designed that's it's meant to be interactive. This function here is very convoluted, and I kind of did it on purpose. So the function here called find and click. Okay. So what this function is doing is executing all these steps sequentially. So what it's going to do is it's going to take a screenshot of the entire screen, convert to base 64, and then run through OCR, and then find the keywords that you're talking about. And then it's then going to look for where that keyword is and set it as a target location. And then that bounding box of the target location, it's then going to isolate that, and it's going to use that as a key to move the mouse cursor there and click on it. Does that make sense? So it's essentially one big function. I haven't counted yet, so let's see if we can count it. So that's one function here. There's another function here. There's another function here. There's another function here. Is that it? These are all hard-coded. I think that's probably it. Yeah, and then it returns a event stream. Yeah, that's probably it. So you get the idea, right? This one big function has lots of nested function inside. And then this is kind of like by design, because every function that I want the chatbot to recognize, you have a declaration here called register function. Otherwise, chatbot is not going to recognize that. But all these functions inside, I kind of isolated them, because if I let's say this function here, there's a helper function for this find and click function. It's image to base 64. You'll take an image and convert to base 64. If I register that as one of the listed APIs, then I have to set up more trigger words. But then if that is the case, what if I have another API that's read the image? Then the trigger words will collapse with this helper function, right? So that's by design, and I'm making a subjective choice here, saying, look, this function, I just want this helper function to be underneath it. I don't want them to be registered as the main listed register APIs. So to answer your question, yes, that would be something to think about. And then you can have one function have multiple small functions inside. And then you're gonna have to think about a good way to design that. My advice there is to prevent yourself from like falling into a rabbit hole, you do it sequentially first. And then once you figure that out, you do it in a loop. I don't know if that makes it clear or makes it confusing. Sure, yeah. But anyhow, so the short answer is yes, it is definitely possible. You can have one API call making small API calls. You just have to think about the design of that and try not to like pick up a rock and drop on your own toes, sort of thing. Okay, I think that's pretty much all I want to say about the presentation. Any questions? Okay, good. Let's take we're coming up an hour. Let's take a 10-minute break. So let's come back at 7:10. And then we'll talk a little bit about slides. And then I want to leave the rest of the time to just question and answering. Okay, so let's take a break and then let's come back in 10 minutes. Okay, so to wrap up the first hour, I just want to say one last thing. If you look at the grading, I put a lot of points on the backend and API. It's because backend and API are the most two important things for this to work. If backend doesn't work or API doesn't work, and then our system design doesn't work, then obviously the whole thing crashes. Front end is of course up to you. The easiest way is to do in terminal. That means don't really have a front end. It's just like Python input, user type something in, and then you print something out using Python. That's no problem at all. If you do that, like you're not gonna get any points taken out. So if you prefer that, that's no problem at all. There are a couple of cool front end though, just FYI. Gradio, Streamlit, obviously you guys heard of that. There's this other thing that's called Open Web UI. That actually pretty much stimulates kind of exactly like a ChatGPT. And then it does it for you in like a Docker image. Okay. So to pull this off, you need to get in Docker image and then do a bunch of customization. It's not completely impossible. I don't know how much time you have. If the question is it possible? Obviously, it's possible. But the way I see it, unless you're a expert in front end, my guess is you might just kill a lot of time. That's the only difference. Let me see if mine is still on. Can show you probably a little bit. This is what the thing look like. You can set up your API by going. Let me move this away. By going to settings, and then you can connect with OpenAI or whatever. Did I not connect this? I should really connect that. I thought I connected in my admin. Did I not? Let's see. Setting connection. Okay, I thought I did. And then you can then control all these things come with the package. Does that make sense? You don't have to physically design this button called model. You don't have to physically design this. And then you can get your web search API in there as well. You can just select the engine and get the API key in there. And then you can keep talking to it. Let me show you. I'm hoping this is live. Is that on? Okay, there we go. So it actually connects to, in this particular case, I have my OpenAI API key in there. So it's actually able to call pretty much every single model out of box from OpenAI platform. And then you can just search whatever you want. You can also, I believe you can also compare and contrast. I remember one of these button is it one of these? Um, yeah, I haven't really played a whole lot about this. But anyhow, I just find this pretty cool. And then um, you can draw pictures in there. But of course, assuming that you need like a multimodal model in there. If it's just O1, obviously there's no real image in there, right? There's no image caption. So all these things are for you to set up. And then on top of that, it cache all of the historical conversation, right? So like if I hit a new chat and I say help me study, it will show up as a new conversation once this is once that conversation has happened. Does that make sense? Um, and then on top of that, you can load this in a container and then deploy, right? So our deploy here, it's this URL. And then you can just log in and then you can start talking to it. So it's the same thing. Let me see. Oh, that API didn't work. I was trying that earlier. I don't think it worked for me. Let me go to GPT and then let me regenerate. This is the one. This is what I have to fix. Yeah, there you go. So GPT worked. The other APIs, it's a little wacky. I have to like do a bunch of bug check, but essentially, everything's here out of the box. You can also do it in your phone, load something in your phone, and then it'll also work. Um, so anyhow, there are a million packages out there for you to do front end. You don't have to like be that JavaScript expert to like code out every single button. If you want to use one of these fancy packages out there, it's up to you, right? You can pull this off. If you're gonna do this, I would just do it locally. What that means is, let me see if I have it here. Yeah, something like this. What that means is you have a package running locally, and then this endpoint is going to be basically on the entire time of the presentation because this image is on. Like I'm physically running this image, and you can see the terminal is continuing to run. And then I think it's either pip install or UV corner. Those are the two pipeline for you to install images for this package. And then what else am I supposed to say? The installation for this is actually fairly easy. I did this on Windows. It worked for me. On MacBook, I think it's even easier because you can just do. I think these couple of lines on MacBook is just like one line, so it's even easier. For me, I tried pip install this. Did not work for some reason. So I had to git clone and then CD in there and then do pip install. Excuse me, not pip install. Sorry, do Docker run, because the artifact on the GitHub repo is actually not a Python package, it's actually a Docker image. So when you do git clone, you actually clone down a Docker image. Um, so yeah, on MacBook, I think you should just be able to do Docker run. It will pull that image directly from Docker, because this is a public image, right? Everyone can download it. Once you download it, just do Docker run, and then you'll be able to run this terminal, obviously, assuming that it's on the entire time when you're looking at the app, like what I'm having here. This is running on the localhost 3000. That's the local inference, and then you can just run your inference that way. Make sense? Any questions? Okay. If there's a whole lot of issues resolving API calls from here and there, my advice is drop the front end, focus on the back end. Like let's say you have 10 hours and then you're like, oh crap, like I only have 10 hours left. What do I do? Well, you want to spend at least 5 hours on back end. You don't want to spend like 1 hour in the back end, copy paste API key in there, and then the other 9 hours just like figure out a Docker image or figure out like, oh, this button looks green or something. There's no value in there, you know. So yeah, so that's pretty much what I mean by focusing on backend and API. And I think with that said, I pretty much covered everything I want to cover in regards to presentation. Any questions? Anyone's able to go on the Excel and then drop their name, right? Okay. Okay. Cool. Awesome. Um, it's open web UI. This one. openwebui.com. I can give you the repo. Openwebui. Oh, this one. You just clone it and then cd in there, and you can do Docker build or whatever, Docker run. Um, this is, I don't think this is a Python package. I mean, this is kind of confusing. They say it's a Python package. This did not work for me. If you guys can get this to work, let me know. But this did not work for me. No, it just straightforward didn't know. Maybe I have a lower version of Python. That's possible. But this doesn't work for me. Doesn't work. I have to do this way. I have to do this way. Docker, like I had to treat it as a Docker image. You do not need to change your code. Once you pull this repo, it's all is there. Yeah. But front end, back end, all of the they actually have a cache database in there. That's temporary database for you to use. Um, for obvious reason, right? Because they need to save the conversation. Like it's here. Yeah. I think that's pretty much all I want to say. Okay. Yeah. Don't worry if you still have questions. We're gonna come back to this. For now, let me say a few words about autoencoder. Um, so um, this is the slides for k-means. But everyone here already know k-means. So once you do k-means, the immediate next topic you should be thinking about is actually autoencoder. Here's the connection. Well, let me talk about autoencoder first. So autoencoder is the type of neural network that take the initial data and then trying to let it go through a bottleneck so that it can reproduce the same initial data, right? So people get confused, like, what is it that we're trying to predict here? Well, you're trying to predict X. And then people also get confused. Well, isn't X the input? Yes, that's X is the input. That's X is also the thing you're trying to predict. Does that make sense? So in code, what do I mean by that is it's this. Same neural network model. You can do whatever. Loss function, whatever neural network model, TensorFlow, Keras, whatever you want. You can do whatever you want. The only thing that's making an autoencoder is the fact that when you're doing dot fit, the X and Y are the same thing. Literally the same thing. Exactly the same. Okay. So you have X string here, you have X string here. That's not a typo. I'm taking the same object, I'm sending in through dot fit method. The first one is the features, the second one is the labels, right? If it's the MNIST classification, it will just be X and Y. So that's the only thing that's different. Everything else is exactly the same. You still need your loss function, you're still doing a gradient descent, all that's the same. So with that being said, here's when things get very interesting. If you reduce the decoder and encoder down to like a single layer, and then no fancy stuff, like no convolution, deconvolution, none of that stuff, just straightforward dense layer, in and out, just one. It turned out that this latent layer actually behaves like a principal component analysis, like behaves like a PCA. And I read this paper a while ago, like some dude actually proved mathematically that those two distributions converge, which is actually very interesting because how could that possibly be, right? Principal component is supposed to be a very simple thing. Like you take the matrix, you calculate the eigenvector, and then you do the inverse rotation to fit the data. Exactly. So how could that be the same thing? Well, if you reduce the encoder decoder to like a single layer, it actually turned out the two distributions look very similar. Anyhow, so that's the relationship here between autoencoder and k-means cluster, and also related to PCA. Another thing that I could show you is these two things, you can break that apart, and that will give you the student-teacher model. So let me show you what I mean by that. So let me grab this pen here. Let's say it's red color. Let's say you grab this, what do you call it in English? Like trapezoid? Like trapezoid, right? You grab this, and then you um, grab this piece, and then you put it down here. something like this. So in this case, let me switch a different color. So in this case, um, you can then take some sort of noise. Let's say this is Z, this is noise. You take some noise. Let's say you generate a picture. This is a picture. And then this is your student model. So this is the learner. And then this picture, you then train it against this. This is a real picture. And then this latent layer is going to be a similarity. And this is your teacher model. This is your learner or student model. Let me just say S. So let me write like this. So this guy down here, this is a student model. This guy up here, that's a teacher model. So you take any random noise, and then you try to use a neural network to create some sort of picture, and then you benchmark this picture against the real picture, and then there's a teacher. This model here, that's the same idea as an encoder, means that you're taking something that is a high dimension, and you reduce the dimension to one neuron. And that one neuron you call a similarity score, or call it whatever loss, or call it whatever accuracy you want. But it's some sort of a loss function here. So the idea is whatever this neural network model is generating, this model up here is then able to say, okay, you just draw me a picture that is 60% similar to this real picture. It's not able to say that. So this kind of, and then you're actually able to train both neural networks simultaneously. So this is the idea behind student-teacher model. Does that make sense? Any questions? So there's code online doing all this for you. You don't have to reimagine the code. But the important concept is you take autoencoder, you there's some sort of relationship between these four things. And I just want you guys to be aware of that. The worst thing you could possibly say is in the interview that autoencoder has nothing to do with PCA. That would be a problem. I've seen that happen before. Some people are shocked and they're like, "What's the relationship between autoencoder and PCA?" Yeah, you say that it's a it's a direct rejection. um, Before I continue, any questions? Yes. Uh, let me answer one question at a time. So the this is just one neuron. When I say cutting half, like I meant that as a as analogy. I didn't mean you physically take the autoencoder and cut in half. Obviously, it's two sets of code that you have to redesign. But the idea is the shape of autoencoder. So the shape of a student-teacher model behave like an autoencoder. So maybe let me show you. I think there's something online. Oh, let me get rid of this because once I show you the code, you immediately gonna get it. Wait. What's it called? It's called TensorFlow, Keras. I believe it's GAN, generalized adversarial network. I might have a typo there. Yeah, this guy here. Once you see the code, it's fairly obvious what do I mean by that? So this is a generator model. So it's actually down the road you draw a picture, right? Why do I say that? It's 28 by 28. It's a picture. This you can think about this as just some random vector. This is just a random vector. It could be 100, could be 1, could be 10, whatever you want. So if I want to draw this out, I can. Here, give me just 1 sec. So I'm gonna do something like this. So you take something like this, like some sort of vector. You're trying to draw a picture. This is a picture. Exactly. Yes. Exactly. So in the beginning, obviously it's going to look like nonsense. This is just random values. It doesn't look like a picture, right? Here is a discriminator. Discriminator is another way of saying teacher. Some people call it critics. Same thing, right? Discriminator. Look at the dimension. It's starting from a picture. Why do I say picture? Because you're starting from a convolutional 2D. If it's not a picture, this code is not going to work, right? So if it's a convolution 2D, that implies the thing that goes in here is a picture, right? So generator is, where's my pen? Generator is something like this. This is a picture. And then somewhere down the road, they give you 1 neuron in the end. So this is just one guy here. Yeah. So this guy, from small to large, this is the student. From large to small, this is the teacher. And then you're training them simultaneously. So what do I mean by that is this. Training them simultaneously means you need to generate a loss for both model and do the gradient descent update for both models. That's what I mean by training them together, right? So here is the training loop. So training step, right? Training step with gradient tape. That means, hey, I'm gonna start to run gradient descent now. Right? That's what that means. You're gonna have 2 outputs. Both models gonna give you an output. The student model is gonna give you an output. The teacher model is also gonna give you an output. So that's why there's 2 outputs here, right? Because you have 2 outputs, obviously you have 2 losses. So you give me 2 losses, that means what? I can do 2 gradient descent, right? Right. So that's what the gradient tape is doing down here. And then whatever remaining, just apply the gradients, do the gradient descent. These last 2 lines of code means you're doing the physical gradient descent, and that is one training step. Like I'm calculating the loss, I'm updating my gradient once. So then you get the idea, right? You just need a for loop and then make this like 5,000 times, right? So that's what's happening here. You have a for loop, and then you just repeat the training step X amount of time. And then every time, every step that you're repeating that, you're updating 2 models. Exactly. Yeah. So these 2 models can be done simultaneously. Same idea. You can do this for 3 models. Right? You can do this for 3 models. As a matter of fact, you can do whatever you want because this code is customizable. Right? I mean, if I want, I can take a 3rd model and I can just have another output. I can have another loss. I'm gonna just take this and then just copy paste down here. Right? You guys get the idea, right? Okay. Cool. So that's how you go from autoencoder to student teacher model. Right. So once again, autoencoder just one model. You train once, that's it. Student teacher model, you're training 2 neural networks simultaneously, and they each have their own loss. Okay. I'm gonna I think there's a little bit more about classification metrics. I'm gonna leave this to next time because I want to leave the rest of the time to be question answering. And then next time we come back, we're gonna talk a little bit about this. Hopefully this will give you guys the knowledge of like what it means like when you say AI judge, right? Like when you have like a logistic regression model, say, oh yeah, this is 70%. How do you evaluate that 70% is fair or not fair or wrong or right or whatever crap like that? This chapter take care of that. Make sense? So we'll leave this for next time. And then I want to leave the rest time to questions. And I'm gonna stay here as long as you guys need, like really like questions about presentation. So we're gonna stop here, and then yeah, we're just gonna leave the time for presentation. I'm sorry, not presentation. Questions about presentation. Yeah. Um, yeah. So yeah, you can hang out, and obviously, if you want to go, feel free to go. I'm not holding you guys hostage. But yeah, no, really, seriously, like ask me any questions you guys have about the final project. Yeah, yeah, go ahead. Wait, hold on. You use different pen. Yeah. I see what you're saying. So the that's a good question. The function doesn't go back and forth. Another function is doing that. Look, it's a conveyor belt, right? The person that's scanning the baggage, it's a different person than drawing a smiley face on the package. It's the person that's drawing a smiley face. His job is just to draw a smiley face. He doesn't care if the suitcase is red or green or whatever other characteristics. It's this guy's job to make that determination. The person that drawing smiley face, his condition is look, I'm only drawing smiley face on suitcase that's less than 50 pounds. He doesn't go back and forth from his position to the conveyor belt. It's the other guy's job. What? Oh, yeah, yeah, yeah. That's a good question. The for the for the data, not this, for the open web UI, like this website, it doesn't really allow. I don't think so. I don't think it allows you to drop CSV or like. I think this just capture means picture, upload file means like whatever PDF or something. Um, I don't think unless this has. If you want to drop CSV in here, I will have to look into the back end. I don't know how it consumes that CSV. Like, like do you need a panda? Do you need because you don't see that in the back end. Yeah, correct. No, it doesn't know that. So you're gonna have to design that. Yeah, exactly. Yeah. 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 Maybe it's helpful if I draw it out. Here, let me share my screen, just in case someone else want to look at this. Um, so um, okay, so what I mean by that is this. Let's say you have we'll just use a box. Let's say you have a prompt comes in, right? And then the first thing you're gonna hit, um, let me put it here. The first thing you're gonna hit is some sort of intent classifier. So this intent classifier is kind of like that guy that's scanning the suitcase on the conveyor belt. The conveyor belt basically means the prompt is gonna keep hitting you. Prompt gonna keep hitting you. The intent classifier is then scanning to every single prompt and basically make a choice. So a choice you can kind of think about like something like this. Make a choice. Which API? So like a API or uh like a chit chat. API or chit chat, right? If it's chit chat, then just go back up here. Does that make exactly? Yeah. So this goes here, this goes here. Yeah. Now that being said, if it's so this means it's chit chat. If it's API, then you have a guy down here. This is the dependency resolver. Dependency resolver. So if it's API, it's gonna hit this guy, and this is obviously yes, it is an API. And then this dependency resolver has a list of APIs in his toolbox. Like a list of APIs basically here, like this. So exactly. So this is like you can kind of think of it as API 1, and then this is API 2, API 3. Exactly. So he is gonna look in this and he's gonna say, oh yeah, I got it. He wants to do a Google search. And Google search maybe is API 1. So he's gonna report back, say, he's gonna do something like this. Sorry, let me go to what's a good way to, I think I'm gonna have to put it, sorry, I'm missing a box here. This is the main LM, something like this. And then let me get rid of this arrow because this now points here, this now points here. I get rid of that. Wait, what? Come on. I want to point it here. Yeah. So now this arrow is then pointing to this guy. So this dependency resolver say, hold on one second. I know you want to make API call number 1. So he's saying API call number 1. And then come back to this LM. Not only is he gonna say that, he's also gonna say, he's gonna say something like this. We need your message. Something like this. And then he's gonna say that to this LM. LM can then pass this back to the user. Yeah, so this you can kind of think about as the user. And then this user gonna say, oh, okay, let me give you the message or whatever. Let me give you the prompt or query so you can do Google search. And then it's gonna come back here again. And then he's gonna say, so maybe there's a decision here, like something like this. Do we have all payload ready? If it's yes, then you can make an API call. So this is the finishing up the API call or execute API. So this is, oops. So this is yes. If it's no, right? If it's no, then he needs to go back up to this chatbot and say, wait a sec, we don't have XYZ. So now you say, it is API call, but we don't have message, something like that. Then he's gonna have to, then this LLM is gonna have to ask the user, what is the message? Does that make sense? So this is the logic here. So there are two decisions that need to be made. One is the intent classifier need to say, this is API call or not. If it is an API call, that goes to a second guy. Second guy says, okay, we want API call number 1 or 2 or whatever. And then in order to make that API call number 2, we need payload 1, 2, 3. And then the payload 1, 2, 3, you either have it or you don't. If you have it, then great, make the API call, execute it. If you don't have it, then ask the user. Yeah. And yeah, I know this is the heavy lifting is these two decision maker. That's the heavy lifting. Is how you use Python to make that happen. You can take my code, of course. You can take the Wing Agent X. It will do exactly this. But as you saw earlier, the Wing Agent X is not perfect, right? There are a bunch of places that it crashes. Um, and and uh, and yeah, and then you can easily. I mean, even if you use Tiny True, it's the same thing. I mean, I can easily come up. Tiny True doesn't even have this. Tiny True is just straight in. You give a composition, and then you're done. There isn't this. There isn't this. Yeah. And then the basic package, Wing Agent, the Wing Agent, this is just one API call. Write the code for me. That's it. There's no back and forth whatsoever. It's just there's one API call here, Mistral AI agent, write the code. You give me Python code, I'm just gonna execute it. So this arrow doesn't exist. Does that make sense? So I would, and again, I understand this is obviously not an easy question. This is actually a very hard question. There are packages out there that's doing this successfully. LangChain is probably the most successful one that does this thing at an enterprise level. But even LangChain, there you could easily come up with an example that LangChain doesn't work, right? So my advice is don't try to make something that this work 100% of the time. Like pick a user, like say, hey, look, this guy only gonna ask questions about machine learning, only gonna ask questions about linear regression. But this guy has no clue what is linear regression. Start from that assumption and work your way down. So if you start from that assumption, you right off the box, you know exactly what's the question he will ask. And if you know exactly what question he will ask, then these things you can kind of take it for granted. Because then in that case, you're building this system for that one guy. So you don't have any caveat cases anymore, right? Because just one dude up there. So I would say start with that. And if you can make it work for one dude and think about what are my other questions that he can ask, then make changes. Yeah. Um, yeah, so let me just copy this and then let me put it here. This is the Wing agent. I'm gonna change it. Don't worry. This is the Wing agent X. Oops. The Wing agent X is exactly like this. Wing agent, it's there's no 2 or 3. It's just one API call. Mistral AI agent. That's it. It's one API call, and then there isn't back and forth, right? You give me write some code for me. It writes a code. If there's Python in there, let's execute it, right? So this is the pattern recognition. Python exist or not. If it exists, then execute it. If no, then goes nowhere. So that's why the first package is very generic. Obviously, a million things could happen here, could go wrong, right? The second package does a little bit more tailoring. In a sense that API, there could be more than one API call, there could be 5, 10, whatever you want. And then this guy here, do we have payload ready or not? Also, it's a additional engineering. Then on the left-hand side, literally just one if statement. On the right-hand side, there's a whole giant function that look into the event stream that says, oh, do we have the name of the message? Oh, do we have message body to send an SMS? Or do we have query to conduct Google search? If we don't have a query, then let's ask the user. So this arrow currently not many people is able to do that. Only a few companies able to do that. Not many people can do that. Um, if you're on the cloud platform, this is very, very obvious. Only Azure has ability to do this successfully. Even at AWS, I know it because I interviewed there. I interviewed at Amazon Q. This arrow is almost non-existent. And part of their feature is to make this arrow robust, and not many people can do that. And it's not Amazon's fault because their API is way too much. AWS has too much API, so no one's able to make this arrow work, and it's not anybody's fault because this is a mess. Yeah. But in this project, this should not be a mess because you are the one that designed this. If you want 3 API call, fine, just 3 API call. That could be API call number one is maybe like a operating system, import OS list directory. So you know one of the file has a CSV in the string, right? That's API number one. API number two is linear regression. Give me X, give me Y, here's linear regression. And then API number three is whatever judge that's like, oh, linear regression R square is too low. You should probably do this and this. So this guy is actually gonna do this and then reports back to the user and do this, report back to the user and do this, report back to the user. And then any single step user can say, oh, stop, then you stop. But ideally what I want to see is that you thought about this part and this part corresponds to this, and then you thought about this part. Yeah, I don't need you to come up with a function that magically works for every single user. That's impossible. But if you can demonstrate to me that you thought about this and you thought about this and you have something that works, then you're good. So these APIs, you normalize that. Just wait. I see what you're saying. My personal preference is these API calls are isolated and they're doing its own task, right? It's funny because the best way I can make an analogy of this is think about this as like the parts of Iron Man armor. Like the arm can fall off, but this whole thing should be able to still run. Does that make sense? Yeah. Just interesting because I haven't seen that. Mm. What you're describing is very much kind of like Azure. Azure AI is actually the Azure Copilot is actually very, very, very smart in a way. So what you're describing is something like this. This is not the end, right? I don't have to let this to go to end, right? Like I could very much do something like this. Look, I could copy this. The first time I saw it blew my mind actually. And I can draw an arrow that let this API call be the user. So this is actually an API. Exactly. So this API, you don't have to let it cut. You don't have to be done here, right? What if this API invoke a whole nother chain of thought? And then this API now is becoming a user. Well, it's a fake robotic user, but user nonetheless. But this API call now can become a user. And this user is now going to kick off a whole nother workflow that's in a similar design, right? So if you can do this successfully, it's going to be very much like Manas AI. That's pretty much what Manas AI is doing. Yeah. DeepSeek is doing the same thing. Sorry, not DeepSeek. ChatGPT Deep Search is doing similar thing. So one of the APIs is actually able to kick off a whole chain of APIs. And this thing can continue to go till you say stop. Yeah. So that's why my advice is don't worry about this part. Like you guys have like today is April 8th, right? All the way to end of April, like 2.5 weeks, maybe 3 weeks. Obviously, I'm not expecting you guys to do all of this. Um, you have maybe think about this as building blocks. This intent classifier obviously need to be a function. It's a Python function that there's a prompt coming, and you say with this probability, it's chit-chatting, or it's an API call. That's one function. And then this needs to be another function, right? This function needs to look at the conveyor belt, which is the event stream that the user. So when I say event stream, let me just show you guys what I mean by that. If you go to OpenAI platform, and then you go to API reference. And what? Oh, yeah. Let me scroll down to where's the payload? There's a place that says payload. Hang on one sec. Let me find a good one. Check completion. There we go. It's this thing. This is an array of dictionary that gets infinitely appended, right? This is a conveyor belt. This array is a conveyor belt. The conveyor belt, people keep throwing baggages onto the conveyor belt. The baggage is a dictionary. The dictionary says role, user, and then whatever the user sentence that they're trying to say. So this thing infinitely gets appended as long as the conversation continues, right? So this is when I say event stream, I'm talking about this bracket here. Yeah. So this bracket, maybe I'll just copy that. So this thing, now let's go back to this graph here. Uh, yes, the short answer is yes. So we're not expecting this to be fed into LLM altogether in one go. Obviously, somewhere down the road, you're going to hit the token limit and it's going to crash, right? In reality, there's going to be a checker, but this is starting to become production. This is going to start becoming production talk. So it has nothing to do with our project. But to answer your question, yes, you don't want this to go indefinitely, right? As a demo, obviously 3 to 5 sentences is perfectly fine. It's not going to blow up your token. But in production, there's a checker somewhere down here that checks the session. Yeah, that tracks the session. If your token size, if this become like 10,000, then obviously you kick off a new session. Yeah. But this is essentially the what the event look like. It's this thing. So it will just continue get appended. Like say, now is a new role. Now there's so user developer. Let's get rid of developer, right? You can think about like this. User say, tell me a joke, right? In this case, the intent classifier will say, this is going to be content. Will say no API call detected. Does that make sense? And then you can pass it back to the LLM. So there's the LLM. And then say, he's just literally going to say a joke, like a joke here. But however, alternatively, let me copy it here. Alternatively, if you say, I want to do a Google search, intent classifier is now going to say, hold on one sec, API call detected, and the API call is API 1. Exactly. metadata knows what this means. Yes, exactly. So now the LM is gonna hold on a second. Now the dependency resolver is going to say, he's gonna do his job first, and then he's gonna say something like, we don't have query. What do you want to search? And then user now have to say, so this is another dictionary here. User now have to say, today's weather in New York City. How do I make this bigger? And then once the user said that, the dependency resolver, so I can maybe just grab this. Dependency resolver say, okay, good, we have all the payload ready. And then in this case, LM is gonna say, content, do you want to execute them? You guys get the idea, right? And then the user now say, it's the user. And user say, yes. And then you execute and make the API call, and then you finish, you wrap things up there. And then whatever this is, it's just the API call. So API, I mean, you can call it whatever you want. I think my go-to one is API executor. It's a guy that executes API call and say today's weather is whatever. Does that make sense? This is just for your debugging purpose, right? For you to design a system, right? User don't see all of it. Correct. No. User don't see all of it. User only see, oh yeah, weather is this. Or if you want me, or user only see this part. Yeah. Yes. Exactly. Yeah. Exactly. Yeah. 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 Sure. Yeah. 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 You can so I think in your case you want to separate your API calls and make sure each API call is do one thing. One API call will be search the internet. And then the result pass back and then pass that to the second API call. And second API call is going to put the result together and find whatever 2013 result. Right. And then third API is to plot a plot. But in your case, the heavy lifting will be the data from here now need to go here, now need to go here. Yeah. Yeah. Another thing of what you're talking about is you can design things in a way that you don't do any of this on the right-hand side, but you can design things in a way that look like this. This guy here could have API 1.1. And then this API 1.1 could have API 1.11. You get the idea, right? So all that's complete up to your own design. Please, yeah. Mhm. In that case, I would say these APIs need to be like one API need to be maybe check the payload. That's how I would do it. So one API will be check the payload. Like if user, because when user is telling you things, doesn't have to be just a sentence, right? Somewhere down here, user can say, um, like this is maybe like maybe this is a F string, and then this is use this data, and then there's a variable here, and this variable is like whatever, like pandas to JSON, something like that. You get the idea. So this way, you're able to pass a JSON in there that's converted from a panda that's from a CSV. So then the intent classifier is going to trigger one of these API calls, and this API call is going to basically unpack this JSON and then say, okay, I see you have 5 columns. The fifth column sounds like it's a target, it's a housing price, right? I'm going to use that, or I'm not going to use that, or do you want me to do it, right? So this API is going to do that job. Literally that one API is his job is to figure out one of these JSON file has a target variable. And let's say fifth column in the CSV, in this JSON file converted from pandas, converted from CSV, is a target variable called housing price. Let's grab that key, and now that becomes the output of what the first API is returning. And then you pass that to the second, the third, or you can pass it sequentially into 1.1 or 1.111 or whatever. Yeah. Um, this design, I mean, I showed you guys how I did it. My logic for how do you define 1.1 or versus 1 and 2 is is the relationship between the two APIs. If I have two functions doing complete different thing, I would just call them 1 and 2. But if executing API 1 requires another function, then instead of calling that API 2, I'll probably prefer to call that 1.1. Yeah. 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 Don't do this. This is crazy. Like I draw this because I think someone asked a question about like what happens after here. Like I'm saying you can kick off another workflow by treating one of these API as a user, and you can kick off this entire workflow and then go through this process again. You can do that, and you have a powerful computer. You can do that probably 50 times in 1 second. You can even parallel this because this can be on one GPU, and then if you have 10 GPUs, you can kick off 10 different workflow same time, right? Um, don't go crazy on that. Like people do that in the industry. Oftentimes they're crazy. um, like myself included, because this is my job, by the way. Like I do this full time. Um, anyhow, point being, don't go crazy on this part. If you just do like if you're just able to pull this off, like this is the part that you're able to pull off. Like user is saying something, maybe there's some sort of data comes in, and then your chatbot thought about it a little bit and say, oh yeah, that triggers API number one, and then you're able to go back and forth a couple of times. And then if you're missing out things for the API, you have another guy here that's able to ask user questions. You just need to demonstrate in your own way that you've thought about these components and the whole thing put together are put together and it works. If I ask you to do a different user and it crashes, that's not your fault, right? Because your system is designed for that particular user persona. Make sense? So I would just go with one user persona. And obviously one of these API call has to be some sort of data science problem. It cannot just be like a Google search, Bing search, or whatever. It has to be some sort of a machine learning algorithm in there. Um, but other than that, if you can put a machine learning algorithm in here, you demonstrated to me that you can put anything in there, right? Because if you can put a scikit-learn in one of these APIs, you can put whatever you want in it. You can put TensorFlow, Torch. I mean, you can put whatever you want. It's just a matter of version control. So obviously, I don't, for this package, for this project, I don't care about that much of version control stuff like that. You just need to demonstrate to me that you thought about this and you have something that works. I don't know if this is helpful. If I were you, I would just like go on Manas AI. Where to go? Here. I would just go on here and click on one of these buttons, and then um, I would just kind of think about like look at the video a little bit. Like I think this one's stop price, right? Is it stop price? Yes. I would just look at this a little bit, and then I think you can you pause this or no? Um, yeah. That's a good point. You can just manually scroll through. So I thought maybe there's a pause button or something, but anyhow, you get the idea. So you can manually scroll this. Like I mean, they have a steps here: 1, 2, 3, 4, 5, all the way to 10, right? Now it's like 7 out of 10. Earlier 6 out of 10. So you get the idea. So each of these steps is basically Manas AI's version of doing this. It's Manas AI trying to go between these two boxes. Here's API, I need this. Oh, I can do it. Now I have to do this. Now it's basically Manas AI's way of doing back and forth. So one thing that's interesting is Manas AI designed their system in a way that this arrow here, it only happens once. Does that make sense? So when they do that, it's kind of like their way of saying, okay, let's just make the system a little bit easier. Let's give the heavy lifting on API itself, and then let's not give the user too much hassle. So that's why in their message they also have this bullet point, right? The bullet point is a game plan saying, look, I'm going to do these 5 things, and these 5 things is tied up to 20 API. And then this bullet point basically show me their cards of saying, hey, look, this arrow, like this arrow here, only gonna happen once. And I'm gonna leave the heavy lifting to between these two boxes. So that's one way out. It'll probably make your life easier. Because in between these two boxes, it's nothing but a for loop. Yeah. Um, that's a good question. So um, yeah, I mean, it's kind of up to you. So like if your game plan like you could say it right at the end of the day your game plan is a PDF or whatever. Like, or end of the day the game plan is um I'm gonna give you a regression table like a nova table if it's a multivariate regression, right? Certainly, yeah, you can design things that way. You then the question is, okay, how are you going to present that table? Like, is it going to be like a CSV? Is it going to be a JSON? Is it like what kind of context are we talking about? So then it opens up that conversation. But in terms of what's the picture? Yeah. So in terms of my expectation, I don't have a whole lot of like you're talking about what happens down like you're talking about what happens down here, right? Is this going to be like a PDF or a table or picture or whatever? I don't really have a preference here. I don't have any requirement there, as long as it makes sense for you, or and it makes sense to the problem. Like if the user asks you for linear regression, obviously this table need to be or whatever PDF need to be a regression table somewhere in there. Um, so yeah, no, I don't have any requirements. Just whatever makes sense. Yeah, I mean, hell, you can present this in I mean, you can design this in like HTML if you want, and you can even deploy this, and then the user can actually get HTML. I think Manas AI is doing that. Yeah, yeah, of course. Yeah, take care. I mean, worst case scenario is to print it, right? Print it on the screen. Right? So you have to like do functions. Oh, you use stats models. Use this. They're both doing regression, right? Um. Oh. Okay, okay. I understand now. I understand now. Okay, okay, okay. Yeah, in that case, yeah, I mean, I don't know exactly what you're doing, but it sounds like you're doing more than just regression. Like you're engineering the model on top of that, right? If that's the case, then I mean, I don't know how you want to present it, but like the easiest way is just print it out. Or you can print it in like, I mean, I don't know, like this just looks like string to me. I mean, if you can print it this way, or you can save as a markdown or whatever. You don't have to code it yourself. I mean, you can just make another LM call and toss that into LM, say, and make it pretty for me. Yeah. Yeah. I mean, well, I wouldn't pick a CSV with like 100. Yeah, I would just go easy on that. Yeah. Unless it's a CSV that you're really interested in, then obviously I don't want to stop you from doing it. Yeah, that's fine. That's perfectly fine. Yeah. Postman is essentially like a curl wrapper. Curl is client URL. Like curl. Like you can just probably Google what is curl. curl means client URL. It's this thing, this API thing. Like you open any terminal window, you can say curl. It's gonna give you some response back if that URL is public. And then you get a 200 response, that means the API call success. And then you get something back, whatever, links or whatever. Yeah, curl it's short for client URL. Yeah, it means you're making a API call. A postman is basically a wrapper, a user interface wrapper of curl. Yeah, same thing, exact same thing. Open source to pay, like, what do you mean, like curl? I don't think so. Oh, Postman. Postman, I'm sure they have some sort of subscription, right? Yeah, I'm sure they have like, yeah, I mean you can upgrade and you can always pay, you can pay for it, right? Yeah, yeah, yeah. Yeah, yeah, exactly. Yeah, we're good? Yeah, please. Yeah, yeah. So a contract for the API is kind of like the metadata, the metadata. So I'm talking about hang on, let me find it for you. Yeah, yeah, yeah. I'm talking about this. So contract means um uh the what exactly is a payload that goes inside of that API. When I say API, I'm just talking about a function that you can invoke it through some sort of URL. Yeah. Yeah. So once again, so API is a function that you can invoke using URL. It could be as generic as whatever, like return hello world, something like that. Um, and then the function has a contract. So the contract of the function is a payload. Is a payload and what it returns. Exactly. So it's essentially a doc string. Um, so if you go to list APIs, it's this thing. So I know for sure this function takes a payload. And I know for sure this payload is a dictionary. And I know for sure in that dictionary is a bunch of strings. If I throw in a payload that's a dictionary of a dictionary, obviously it doesn't work, right? Because that's not a contract. So when I say contract, I'm talking about the agreement that we're making for this function to be invoked successfully. So one of the like during presentation, if I see you design a new API like this here, let's say presentation, you say, okay, this is my chatbot. You can ask this question and then it worked, right? Here's a result. Here's a PDF or whatever. And then I'm gonna look at your API. I'm gonna say, okay, what is the contract for API 2? Right, exactly. So you're supposed to answer. You're supposed to answer. Yeah, I know exactly what the contract is. You're supposed to take a payload that's JSON file. You're supposed to take a payload that's a dictionary, and then you're supposed to return a dictionary. So you should know exactly what the contract is too, because you wrote this. Exactly. Yeah. Exactly. Yeah. Yeah. Yes, yes, yeah, yeah. So the contract or payload or requirements of an API, I'm talking about like these guys. Yeah, exactly. Yeah, exactly. Exactly. Yeah, 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 yeah. Exactly. Yeah, yeah. Exactly. Exactly. Yeah, yeah, yeah. Exactly. Uh, so if you throw this function on Lambda, you can do that. You just have to make sure because Lambda has a particular requirement for the it's Lambda's contract. Lambda has an innate contract that they only allow certain data structure to go in and out as payload. Otherwise, you can't make the API. You can't add API as a trigger. So you just have to be aware of whatever you're designing, um, fit in the Lambda's contract. And you can do this using ChatGPT. You don't have to magically figure out all by yourself. Like whatever works locally in your Python code in a Jupyter notebook, toss that into ChatGPT. Say, I know this locally works. Give me like turn this into a Lambda function that I can deploy on AWS, and they'll do it for you. Yeah. The doc string is this thing. It's a literally document string. Yeah. Yeah. Doc string. Wait, what do you mean trigger? The output the payload is the like what goes into the function. And then oh, you're talking about payload coming out? The payload coming out can be whatever you want. Usually it's some sort of JSON file. Yeah. 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 Yeah, exactly. Yeah. Good. You can always email me if you have questions. Yeah.